So in example 5, we've been actually given some x's to work with. So we're going to plug these x's into the equation and generate the y that's related to it. So negative 3 times negative 2 is positive 6, plus 1 is 7. Negative 2 times negative 2 is positive 4, plus 1 is 5. 0 plus 1 is 1. And then we get negative 2 times positive 4 is negative 8. Plus 1 gives us negative 7. So showing these coordinates on my graph, I'm going to go negative 3, positive 7, negative 2, positive 5, 0, and 1. Okay, and at this point I can see that they're lining up. 4 over negative 7. Okay, I can see those coordinates line up. When I put my ruler to it, I can see that they are definitely in a straight line. And again, it's not these coordinates that I'm interested in. It's actually the straight line that I want. Okay, so any points that you would have used to calculate to this relationship would have ended up on that straight line. Now we're getting into this idea of what describes this straight line. It's going to be the angle or slope and the position of this line. And the ratio of change is what we are going to look at as the slope. And it's how the x changes relative to the y, or more specifically, how the y changes relative to the change in x. And to show that, I'm going to draw in a slope triangle. And I could use any 2 points. So we're going to use these 2 points here. And I can see as my change in y, from the left-hand point, I've gone down 1, 2, 3, 4, 5, 6. So my change in y is negative 6. So my change in y to change in x is going to be negative 6 for the y. And then the change in x is going to be, in this direction, it's going to be plus 3. So plus 3, and we can write this ratio of change as a one-number slope. And we call that slope m, and that slope is going to be negative 6 over positive 3. So we say we can write that as a one-number slope of negative 2, or negative 2 to 1. The y-intercept is where the graph crosses the x-axis. Okay, and this actually helps us locate the convenient way to locate a point on the graph. And so the y-intercept is going to be when x is 0, and in this case, it's when y is 1. In fact, it happens to show up on our table as well. So the y-intercept is when x is 0. We could go the other way around. We can just start with our graph and fill out our table. We can use any points on this graph for the table. I'm just going to use the points that are dotted there. So the first point is going to be 1, 2, 3, 4, 5, 6. So negative 6 for x. And for y, we go 1, 2, 3, 4, 5, 6. So positive 6 for y. For the other point, it's going to be negative 3. It looks like positive 4. The 0 or y-intercept is going to be at positive 2. I'm going to be at 3 and 0. And it looks like the ratio of changes for every plus 3 on the x, it looks like I'm going down 2. And this is where I would see the ratio of change in my table. It's on the outside. It's the changes. Lastly, I have 6, negative 2 as my coordinate. So the ratio of change then, I can use any 2 points. I'm just going to use the first 2 points. I could use a bigger triangle or smaller triangle. And I can see that it's gone down 2. I can see that right here. And it's gone plus 3, which I can see right here. So the ratio of change is going to be, we're going to show this as a fraction. It's going to be the y on top over the x on bottom. So it's negative 2 to 3 is my ratio of change.